Okay, now that we have audio, which is always beneficial, I will do a short run through of the solutions I just did without audio. So here they are. Again, this is from homework 1 in your My Math Lab. So if you go to homework 1, algebra review. When you're dealing with exponents, the exponent can come in three different varieties essentially. It can be positive, it can be negative, or that exponent can be a fraction. So in the case where the exponent is positive, recognize 6 to the 8th power is 6 times 6 times 6 times 6, 8 copies of 6 being multiplied, right? 3 squared equals 9, because that's 3 times 3. Again, students tend to conflate this exponent with multiplication. This is not 6 times 8. This is 6 times 6, 8 times. When you shove it in your calculator, you get this answer out. When you're dealing with a negative exponent, so that negative exponent can either come when your base is in the numerator position or when your base is in the denominator position. In either case, when you have a negative exponent, it says send it to the other side. So if you have a negative exponent in the denominator, it says send it to the numerator and make it positive. Contrast that with if you have a negative exponent in the numerator, it says send it to the denominator and make it positive. So when you're looking at something like 8 raised to the negative 2, that says, well, that's 8 to the 2 in the denominator position. So 8 raised to the 2, that's 8 times 8, which is 64. So 8 to the negative 2 is 1 over 8 to the 2, which is 1 over 64. When you're working with a fractional exponent, that fractional exponent is also a radical, or there are two different notations for the same idea. Fractional exponent is a radical, right? So if it's a to the 1 over 2, that's the second root of a, which means close to nothing. So for instance, consider 9 raised to the 1/2 power. That would be the square root of 9, which is plus or minus 3. So when you have something like this, and really all we're driving towards here is being able to represent a fractional exponent as the proper radical. So 169 to the 1/2 power is 169 square root thereof. This notation tends to not be received well by students. Personally, I don't like these radicals. I think all exponents should simply just be represented as the fractional exponent that they are. So consider the nth root of a is a to the 1 over n. So the square root of 169 is 169 to the 1/2 power. So that's how you want to think about exponents. Really, the two very important pieces would be this one and this one. When I say this one, I mean these. This is simply checking to see if you recognize that a 1/2 power is the square root, or a 1/3 power is the cubed root. Next, when we did something like this, 4 to the 11 divided by 4 to the 6, recognize that can be represented as 4 to the 11 divided by 4 to the 6. So this division symbol, these are the same idea, different representations. Recognize when you're working with a fraction, you're taking 4 to the 11th, dividing it by 4 to the 6th. 4 to the 11th is 4 times 4, 11 times, right? 11 copies of 4 being multiplied. And we're dividing by 6 copies of 4 being multiplied. So recognize we have multiplication going on upstairs, only multiplication going on upstairs. We have only multiplication going on downstairs. So 6 of these copies in the denominator will undo 6 copies in the numerator. which will leave behind 5 copies of 4. 1, 2, 3, 4, 5, right? Because you started with 11 and then 6 went away, so you leave 5 behind. In the denominator position, we get the placeholder of 1. 4 times 4 times 4 times 4 times 4 is 4 to the 5th, and we're dividing that by 1, which is redundant. Anything divided by 1 is that anything you started with, which is 4 to the 5th. Crunch the numbers into your calculator and you get 1024. When you're working with equations such as this, what you want to keep in mind is you want to collect like terms. So you want to collect x's with x's, y's with y's, constants with constants. So when we had 9x minus 3 equals 78, we want to collect constants with constants, which means we want to condense this minus 3 and this 78 together. So we want to push this minus 3 to the other side of the equation, so that way it will be absorbed with this 78. To push this minus 3 to the other side of the equation, we need to add 3, right? Subtracting 3, adding 3, these two will undo each other. Consequently, we also need to add 3 to the other side of the equation. So 9x minus 3 plus 3 leaves behind the 9x. 78 plus 3 gives you 81. Now we're looking at 9x equals 81. We need to peel away this multiplication by 9, hence we divided by 9. We need to also divide our other side of the equation by 9 to maintain equality. Dividing both sides by 9 gives us x equals 9. Similar type of story for this equation. 7 plus y equals 12. We want to collect constants with constants, x's with x's, y's with y's. So we want to push this 7 and this 12 together because they are both constants. So we need to get this positive 7 to the other side of the equation. So this is a plus 7, so we need to subtract 7. We also need to subtract 7 on the other side of the equation to maintain equality. 7 plus y minus 7, well, the 7's undo each other, leaving behind 0 plus y. Well, 0 plus y is simply y. And then recognize on the right-hand side of the equation, we have 12 minus 7. 12 minus 7 gives you 5, and then hence our solution of y equals 5. These are similar type of story, just more pieces floating around. The idea is the same, collect constants with constants and y's with y's. So I decided to move my constants around first. I have this plus 8 on the left side of the equation, so I subtract 8 on the left side. Consequently, I also need to subtract 8 on the right side of my equation. 4y plus 8 minus 8 gives you 4y. 3y minus 2 minus 8 gives you 3y minus 10. Now, I have my constants on one side of the equation, so it would be nice if all my y's were on one side of the equation. So I subtract 3y, positive 3y minus 3y, these two undo each other, leaving behind the minus 10 on the right-hand side of my equation. Positive 4y minus 3y, so think of it this way, you have 4 y's, you're taking away 3 of those y's, leaving behind 1 y, which you have 1y equals 10, which is the same as saying y equals negative 10. I'm sorry, I should have said 1y equals negative 10. I misspoke. This guy is a very similar beast. Recognize, collect constants with constants. So this plus 3, we want to get rid of it on the left-hand side of the equation. So we subtract 3. We also need to subtract 3 on the right-hand side of the equation. X divided by 3, and then you add 3 and subtract 3. Well, these two undo each other, leaving behind x over 3. And then on the right-hand side of the equation, we have 8 minus 3, which gives us 5. Yes, this 5. So really, what I'm looking at is x over 3 equals 5. Well, I need to undo this division by 3, so hence I need to multiply by 3. If I multiply the left-hand side of my equation by 3, I also need to multiply the right-hand side of my equation by 3. 3 upstairs, 3 downstairs undo each other, leaving behind just x, which is what we wanted. And then 5 by 3 gives you 15. So for this guy, let's go ahead and just focus on this bottom piece. We have the quantity x minus 5 squared equals 64. So the first thing we want to do is so keep in mind the goal is to isolate x, get it alone and by itself on one side of the equation. So I need to peel away this square. To undo a square, I need to take a square root. So I take a square root of both sides of my equation. Square rooting the left, while square rooting undoes my square, leaving behind my x minus 5 quantity. Square rooting 64, you're really asking yourself, what number can I multiply by itself and get 64? Well, 8 times 8 is 64. Also, negative 8 times negative 8 is 64. So, the square root of positive 64 is plus 8 and minus 8. So, we need to solve this equation. Now, because this equation, we have essentially 2 separate pieces on the right-hand side of the equation, I need to break up this equation. So I'll solve x minus 5 equals positive 8, which I do here. And then I will solve x minus 5 equals negative 8, which I do here. These account for both solutions that were produced from taking the square root. X minus 5 equals 8. Well, to isolate x, I need to add 5 to both sides. So 13 is one solution. For the other solution, x minus 5 equals minus 8. I need to add 5 to both sides of the equation. Adding 5 to negative 8 gives me negative 3. So negative 3 is my other solution. So keep in mind, to undo a square, we need to introduce a square root. When we introduce a square root, we get 2 solutions. The last problem, we had y over 2, quantity squared is equal to 36. Well, to undo a square, I need to introduce a square root. So I square root both sides of my equation. Square rooting the square on the left isolates my y over 2 piece. So I have this y over 2, right? It was y over 2 quantity squared. I took the square root. The square root kills off the square, leaving behind this piece. On the right-hand side of the equation, square root of 36. Again, remember we get 2 solutions, one positive, one negative, when we do a square root. So we have y over 2 is equal to plus 6, as well as y over 2 is equal to minus 6. We need to solve this equation in 2 pieces. So the first one I did was y over 2 is equal to positive 6. So recognize I need to undo that division by 2 on the left-hand side, so I multiply my left-hand side by 2. Similarly, multiply the right-hand side by 2 to see that the solution is y is equal to 12. For my other guy, pretty similar, y over 2 is equal to negative 6. I need to undo this division by 2. Again, I want to isolate y, get y alone and by itself on one side. So I need to undo this division by 2. I accomplish that by multiplying by 2. Consequently, need to multiply the right-hand side by 2 to maintain equality, and then carry out, crunch the numbers to see y equals negative 12 is my last solution. All right. Thank you for listening. Good luck. Send me an email if you have questions.